Here is an important problem that is going to give us some properties that the diagonals of a rhombus have. This is going to be a proof to show that the diagonals of a rhombus bisect each other. They are also perpendicular to each other, and they bisect the vertex angles of the rhombus. So here we go. We're just given any old ordinary rhombus with its diagonals, AC and BD. We're trying to prove again that it's bisecting all of these vertex angles and that they bisect each other, meaning that this side of the diagonal will be equal to the other side of itself, and the same thing with about this diagonal, and that they are perpendicular. I believe I already said that. So here we go. Not a long proof at all, only I believe 4 steps. But this is an important problem to be able to use in the future, to be able to say, hey, we got a rhombus, the diagonals bisect certain angles. We have a rhombus, we know that they bisect each other. Oh, we have a rhombus, we know that they're perpendicular to each other. And so, if we know those things, it helps us in future proofs, making our job a lot easier. So, number 2, after we have stated our given, we're going to say that AB equals BC, which equals CD, which equals DA. And that's simply because it's a rhombus, and we've already proven, I believe in Corollary 19.1, that all the sides of a rhombus are equal. And so that is because all sides of a rhombus are equal. Number 3, I can state now that we have a lot of isosceles triangles. We can see, since all these sides are equal to each other, we have an isosceles triangle here, we have an isosceles triangle here, we have an isosceles triangle here, and we have an isosceles triangle there. And so we can state for number 3 that triangle ABC, and I'll even just say triangles ABC, BCD, CDA, and DAB are isosceles. And that's the definition of isosceles triangles. They have 2 sides equal to each other, so that would be the definition of isosceles triangles. And then number 4, we can already state every single thing that we're trying to prove. We can state that they are bisecting the vertex angles. We can, and I say vertex angles, I'm talking about in these isosceles triangles. I can say that they bisect all of these angles of this rhombus. I can say that they bisect the diagonals bisect each other, and I can say that they are perpendicular to each other, which is absolutely awesome. It's from a previous proof we've done before, that if we have 2 isosceles triangles that share a common base, then we know the line joining the vertices, or the vertex angles, the line that joins this vertex and this vertex, it bisects the vertex angles, and it is the perpendicular bisector of the common base. And so we can even say the same thing about these 2 isosceles triangles. They share this common base, and so we can say the exact same thing. And so it would take a whole lot more work if we didn't have that in our tool belt. We would take a whole lot longer to try to prove that, yes, we could make congruent triangles, we could try and all these different things. It would just take a whole lot more steps. But when we have those kind of things in our tool belt, it makes our job a whole lot easier. So I can say that AC bisects angle A and angle C. I can say that BD bisects angle B and angle D. I can say that AC and BD bisects each other. I should say bisect each other. And I can also say that AC is perpendicular to BD. Again, if two isosceles triangles share a common base, the line joining the vertices bisects the vertex angles and is the perpendicular bisector of the common base. Super simple proof if you remember certain things we've gone over in the past. And so if we would remember that, hey, we have a lot of isosceles triangles, and we could recognize that. That's another thing. Not only, we might know that if I were to point that out, if I didn't point out that we have a lot of isosceles triangles, you might not have ever even thought of using that tool that's in our tool belt. So you have to train your eyes to be able to see, oh yeah, I see quite a bit of isosceles triangles here. And so just keep training your eyes looking at the big picture, because sometimes we can get so focused on the small details and really focus on these small angles. Oh yeah, blah, 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 blah. And you could probably still prove things. There's so many ways to prove what we just proved, yet sometimes there is a faster, more efficient way. So just keep your eyes open. Don't always focus so much on the small details, even though sometimes that is important too. You got to be well-rounded when it comes to these proofs. But now we know some great properties of the diagonals of a rhombus. That they bisect the vertex angles of this rhombus, and they're perpendicular bisectors of each other.